Okay, greetings everyone. Thank you for joining us. My name is Samuel Lukotun. I am a solutions engineer here at CircleCI. And with me today is Arun Balakrishnan from ShiftLeft. He's the director of product management there. And today we'll be talking about how you can incorporate ShiftLeft and CircleCI orbs in order to secure the pull requests you submit on your platform. So as part of that, to that effect, we're going to be talking today. I'm just going to do the brief introductions, and we're going to talk about a brief intro into CircleCI and what the orbs mean for our platform. And then I'm going to pass the control over to Aaron, who's going to talk a little bit about the ShiftLeft product overall, and then give us a few examples. So just go through a brief demo of how ShiftLeft and CircleCI work together. At the end, we're going to open the floor for Q&A, but anytime during the presentation, if you have any questions that come up, feel free to submit your questions via the Q&A button at the bottom of your Zoom window. You can submit your questions there, and then as we go through the webinar or at the end, we're just going to address those questions together. So overall, at CircleCI, our mission is just to make it as easy as possible for everyone, every development team to go from an idea they have to delivering that idea as an application to their customers. And at CircleCI as a company, we were founded in 2011. Currently, we have over 280 employees, and we're a distributed team spread across five continents at this moment. We help teams build better software, help them build it quicker, and help them build it more reliably in the sense that you're not worried about introducing any quality concerns into your product. We're currently the world's largest shared CI/CD platform, and as of the moment, we're built for cloud, and we run over 1 million plus builds per day on our platform. Some customers that are currently using us, this is not an exhaustive list for our customers, but we have customers like Stitch Fix, Spotify, Cruise, and Coinbase running builds on our platform at the moment. So where does CircleCI sit in the tool chain? For those who are not familiar with CircleCI's product and the tool overall, we sit as a continuous integration and a continuous deployment tool between your VCS and your deployment platforms. So you can think of CircleCI as a platform that glues everything that goes on in your GitHub, your Bitbucket, all the code you submit to your repository. We are the platform that stands between all that code and all your deployment targets. So if you're going to be pushing code to, let's say, Docker or Heroku or AWS, for instance, we're the tool that automates the delivery of your code as building the application and then delivering them to your target endpoints. And for those who are not familiar with the platform, I'm just going to go through a quick demo of what CircleCI looks like. And what I'm showing right now is just a workflow of a sample project I was working on. So if you're coming from, let's say, Jenkins background, for instance, you'll be familiar with the idea of builds, jobs, and the workflow. And what CircleCI does here is we have this visualization that generates this dependency graph, so to speak, of what your jobs look like for that pipeline. And so one of the features that CircleCI provides on the platform is the ability to parallelize jobs. As you can see here, I'm running these 3 jobs in parallel because they don't have a dependency on one another. This allows me to optimize the speed and the build times of my pipeline. Furthermore, one thing I want to point out is each one of these jobs here, these are all individual tasks for your pipeline, and you can configure each one of these with its own execution environment. So let's say, for instance, these builds I'm doing here, if I wanted to build an application, if I wanted to build it and test it on, let's say, Mac, on Windows, and Linux all at the same time, I can have all of those jobs running in parallel, and I can configure each one of those environments to have a different operating system as well as a different tool chain. So on this platform, you don't need to provision independent workflows for the different platforms that you're going to be running your test or your product on. If you're going to be running your test across multiple operating systems, across multiple versions of the same product, then you can do that directly, conveniently from CircleCI without having to provision separate infrastructure for all of those SKUs. One of the things that having this feature, being able to show this dependency graph visualization, that it gives you an opportunity to identify quickly where bottlenecks might be in your pipeline, as well as when there are errors in your pipeline, it allows you to quickly identify them. So one thing I'm going to show now is I'm going to show that same workflow, but instead now I introduced an error into one of the test steps. And with other platforms, you're coming from Jenkins, for instance, when something goes wrong in your platform, the way to debug it, the way to identify what has gone wrong would be to go through and sift through the log files. That could be time intensive, but on CircleCI, we make it clear where that error has occurred. And furthermore, you can actually click directly on this job, and it gives you detail about what went wrong in that job. So in this case, I manually introduced a failure into that test job, so I can actually quickly tell. But if you were a developer, for instance, working on this, and this was an unexpected failure, you can see that quickly I can dive right, like just within 2 clicks, I know where my error is coming from. And if I need to debug this, I have a clear error statement that tells me what might be going wrong for that particular job. And one other handy feature I'd like to point out before we move back into the content of the webinar, is the fact that you can rerun this job with SSH enabled on here. So I can come here and can rerun the job and rerun it with SSH. And what this allows me to do specifically for failed jobs is that I can kick off that job with the same parameters and then connect into the container that's running that build for me. And this just accelerates how quickly I can debug problems, because now I can go back into the container as it's running and try to introspect in real time to figure out what might be going wrong. And so just for the sake of time, I'm going to stop right there. But these are just a few features that we have built into CircleCI, into the platform. And compared to something like Jenkins, for instance, which Jenkins is more open and more flexible, where you build functionality into the platform based on the plugins you select. With CircleCI, we try to be a more full-fledged, more full-featured platform that gives you everything that your development team needs right out of the box. If you have any questions about anything I've covered on CircleCI so far, about any of those features, please feel free to submit them via the Q&A button, and we can address them at the end of the webinar. So going back to the slides here, and once this loads, okay, so orbs, these are the main big features that we're here to talk about today. And before we actually go into orbs, let me point out a quick thing on the CircleCI platform that's going to make this a little bit, it's going to help this make a little bit more sense for you. So if we go back to our jobs in our workflow here, and if I select one of these jobs, the configuration on CircleCI that allows those jobs to be laid out in that fashion all happens in a YAML file that you check in with your code into your repo. So what that looks like here is just a file that just specifies all the keywords, and you specify the environment you want to run in, and you build in the command. So you're not learning a new language, you're not learning this domain-specific language in order to implement your pipeline. What we're doing here is we're just providing, this is really just specifying the data that's going to be running on the platform. You're giving it, for instance, here I'm specifying that I want to run this job on Docker. Then I give it the steps that I want to run, and each of these can be a command that runs via the terminal. So in terms of being able to ramp up and being able to implement pipelines and logic within for your pipeline, for your project, you don't need to learn anything additional. You just need to look at the documentation, pick out the keywords you need, write that into the YAML file, check that into your repo, and then you're building on CircleCI. So where the orbs come into all of this is that an orb is your reusable, shareable package of CircleCI configuration. So if I go back to that page here, this section I've highlighted here, this is a section of my config file. If I have a project that reuses this section or this similar logic, and I have this repeating across multiple projects or across multiple config files, instead of copy and pasting this logic into all of those files, I can write this and templatize it separately in a separate YAML file that we'll call an orb. Then we're checking this up into a registry on CircleCI, and that allows you to import this logic into every other config file you're going to be using without needing to rewrite it from scratch. And so this is a powerful feature that allows teams to share and reuse logic or any configuration that they know is going to be common across multiple files without having to continuously re-implement or rewrite the same logic across all the different files that they're using. So going on to the next slide, what I just pointed out is like all the different sections. An orb is essentially just a section of a config file. And in our config files, we have things called jobs, we have executors, and commands. The jobs were those individual boxes I showed in that workflow, which are just chunks of logical tasks you want to execute on your pipeline. The executors themselves you can think of them as the environment within which you want to run those jobs. So the executors on CircleCI that we support can be either a Docker environment, you can do that in a Linux, Mac, or Windows virtual machine as well. And also the commands then on CircleCI are just, like I said, any of those things you can run via the terminal that you would run locally. You can write those into your config file, and then we'll run that on the container that's running your builds. So any one of these three parts or chunks of your config file can be templatized, checked in as an orb, and then shared across multiple teams. And one thing that's cool about the orb function for us on CircleCI is that as a company, we actually work with some of our technology partners ahead of time to pre-write these orbs for our customers. So for instance, if you're building a lot of integration where you're doing a lot of checking or you're doing a lot of deployments to AWS, for instance, we have AWS orbs that allows you to integrate with ECR or with a container registry, or if you're going to be deploying to containers, you can do that directly from the orbs without needing to rewrite the logic that would need you to do that in the first place. So this slide just shows a list of some of the orbs that we've already pre-built with some of our partners and some of them that we've written ourselves. So my encouragement to you and to your team, so if there's any tool, any third-party integration that you're going to be needing as part of your pipeline, instead of, before you start writing that logic for yourself, go to the orb registry, search around and see if we've built an orb, or if another customer has built a similar orb that you can use within your pipeline. So if you need more information, if you need to do into documentation or to read some blog posts, these are some links that contain some useful information about OBS and the CircleCI platform overall. This slide is going to be shared with all attendees, so you don't need to write this down or screenshot this. We're going to be sharing this so you have access to all of these links. And with that said, I'm going to be passing control over to Aaron now, and he's going to talk a little bit more about how ShiftLeft and CircleCI play together. Okay, over to you, Aaron.
Perfect. Thank you, Sam. Thank you for that introduction. Let me start sharing. Okay. Sam, can you see this?
Still loading on my end, and now I can see it. Perfect.
Excellent. So yeah, good morning, good afternoon, good evening, folks. Thank you for joining, wherever you might be joining in from. And really excited to have this webinar together with CircleCI and Sam. We here at ShiftLeft, we are a startup, Series B funded. We were founded in late 2016, and we are in the application security space. Right? And then we partnered with CircleCI. In fact, every single demo that I show to my prospects and customers, I normally start with CircleCI for the CI integration because it's just so easy to use. And it truly delivers on the value that we here at ShiftLeft are trying to promote, wherein it's some application security and code analysis, which is purpose-built for developers and really integrated into a CI pipeline. So what do we do here at ShiftLeft? ShiftLeft was founded primarily to solve some of the issues that we've been seeing in the AppSec space. The code analysis market is not a new market. It's been in existence for more than 20 years. And most of the legacy vendors that are in the market today are at least 15 years old. Most of those tools were made for a different era altogether, right? So like imagine developing an application 15 years back, that's 2005, when you didn't even have a concept of, say, public cloud. It was not so popular. You wouldn't have a concept of microservices. You had monoliths. You had full control over the entire stack. You would have hardware dedicated to these resources. And that was a totally different way of developing software back then, right? And even updates to software happened, say, once in 3 months. Like you would have a 3-month-long project, a waterfall model, and you would have an update at the end of it. And fast forward 15 years, now we have customers who are developing and releasing updates, say, 3 times a day. And security just cannot be an afterthought when it comes to such quick deployments in this modern SDLC and like CI/CD pipeline. Right? So speed is of very high priority. And when you are trying to address such high velocity of development, and you have a security tool in place, if that security tool is providing a lot of results, which say maybe a lot of false positives, which might not be as accurate, which you would have to do a lot of triaging and evaluation to see what is real, then it just doesn't work, right? I mean, I can be extremely fast, but if I give you 20 pages of results, then yeah, security is not catching up. Right? So ability to prioritize what you find as vulnerabilities, and ability to have a low false positive result, ability to have a high true positive result, these are also very critical. Now, a lot of legacy code analysis solutions in the market today look for what we call as technical vulnerabilities. Now, what are technical vulnerabilities? These are like SQL injection, cross-site scripting, remote code execution, directory traversal, right? And these are findable because a lot of them follow certain patterns, right? So it's pattern matching, to say the least. Now, you can imagine when you do something based on patterns, it is inherently susceptible to false positives. That's one. And two, you cannot do something which is not fitting a pattern, right? So what we call as business logic flaws is things like, say, you have authorization bypass, authentication bypass. You could have sensitive data leaks. You could have insider attacks like backdoors or rootkits or logic bombs in your software. And a lot of these things don't match patterns. That's one. And a lot of these things are relevant only for your application, right? So it's very context sensitive. So you cannot have a generic tool that can find such problems in your source code. And finally, we understand, yes, I could pinpoint the line of vulnerability in an application, but most big organizations take surveys, say, on average 3 to 6 months to fix such a vulnerability. Why is that? Well, one, the vulnerability could be in a library which you don't even own. It could be in some part of the source code which is like maybe even older than most of your developers in the company, right? You have not even touched that code in years. Or maybe you are like, okay, it works. Why do I fix something that's not broken, right? So we understand that. So not everything can be fixed in code. And hence we realize something you need to have in production, which could still protect you even if you are working on or you're delaying the fix in the application. Right? So it's the 4 challenges that led us to do things here at ShiftLeft. Now, before I go into what we can do, I want to quickly touch on how we are able to do what we do here at ShiftLeft. So our key innovation is what we call as a code property graph. What does it mean is underlying it is a representation of the source code of your application. Right? So this came from our chief scientist, Dr. Fabian Yamaguchi, who's based in Germany, and this was part of his PhD thesis. What it primarily does is it's a single data structure representation of your entire application. How is it different from other vendors? Well, most solutions, if not all in the market today, does it as distinct data structures, right? So you have like the abstract syntax tree, the AST, you have the control flow graph, you have the program dependence graph, and all of these are distinct data structures. And then what these tools do is then try to correlate among these to find vulnerabilities and patterns. Now, you can imagine when you're trying to correlate something, it is going to be compute intensive, it's going to be memory intensive, it's going to take a lot of time, and it is prone to errors. Right? So having a single representation makes it much easier in all these aspects. Now, it might sound great on paper, but does it work? He, as in Dr. Fabs, he went on to present this at the IEEE conference here in the Bay Area in 2016. And as part of that presentation, he went on to reveal 18 zero-day vulnerabilities in the Linux kernel, which were previously unknown. Now, to put that in context, the Linux kernel is one of the most reviewed source code in the world, right? And to find 18 previously unknown vulnerabilities at one go is unprecedented, and it's really commendable. And then he did that using this graph representation. Right? And we went on to also run this against the OWASP benchmark, which I'll give a bit more detail. And all our products here at ShiftLeft is built on this core technology. Right? That's what enables us to do what we do. Now, what does it enable us to do? Well, one, our code analysis is extremely fast. Right? To put it in context, when we say we can do 1 million lines of code in less than 15 minutes, the closest competition is around 40 times slower. Right? And second, I said speed alone is no good if the results are no good. We are extremely accurate. I'll show you the OWASP benchmark results. On that, we are 3 times better than industry average for commercial tools. And the way we do the code analysis, another thing that it enables us to do is to be comprehensive. Now, what do I mean by comprehensive? A lot of applications in big enterprises, we realize less than 50% of the code is actually written in-house, what we could call as custom code. Most of it comes from dependencies and libraries and frameworks that you use. And you might even invoke like APIs and something from other frameworks. So a lot of your application logic is not what you write in-house. And now if you were to only scan what you write, well, then you're blind to more than 50% of your application, right? So you need to be scanning your entire application stack. And the fourth one is something I touched upon in the beginning is we don't just do technical vulnerabilities. We also do what we call as business logic flaws. So that includes the things that I said, things like authorization bypass, authentication bypasses, insider attacks, even things like sensitive data leaks, which could lead you to be non-compliant with things like GDPR and CCPA and HIPAA, etc. And as a platform, I mentioned we are purpose-built for developers. And so we want to encourage you to scan more, right? Like it is not something you do one-off. A lot of vendors penalize you for scanning more. We really don't care. We provide unlimited concurrent scans. And then the speed at which we do things actually encourages you to scan more frequently, right? Because there's a lot of research which goes on to say it's much easier, much more cost-effective to fix a vulnerability at the source than wait for it to go all the way into production, find it as an issue, and then try to fix it later. Right? And it's extremely easy to use. I'll show you a demo wherein with CircleCI, it literally is like within 15 minutes, you can go from scratch to integration and start scanning your applications. It's that easy. Now, a couple of slides on a couple of the claims that I made. So this is the comparison between us and competition. Lines of code is how big is your application, and this is the time comparison it takes to scan. Now, if you look at it, it's say a million lines of code in less than 15 minutes. It's pretty much the fastest in the industry today. And to give you a comparison, so if you do a million lines of code with us in 14 minutes and 35 seconds, this is on average across what we see across our customer base. Competition, what we have heard from customers that use those solutions, it takes upwards of 9 hours to do that. And so that's almost like a 40x multiple. And the OWASP benchmark, so this is a open benchmark published by OWASP for code analysis solutions. When we ran it against, or when we ran it and got a score, and when we saw the score from other vendors, this is what it was like. So we came at 75, and the industry average is at 26. Now, what does this 75 mean? It's calculated off two metrics. One is true positive rate, and one is false positive rate. Now, true positive is if I have 10 vulnerabilities, can I find all 10? We were the only vendor who could find all the vulnerabilities published in the benchmark. And the false positive rate is if there are 10 vulnerabilities, and if I say I can find 12, that means 2 of them are false positive because we know there's only 10 in there in the first place. So that's the false positive score. So combining these two is what OWASP benchmark comes out with the final score. And so we came at 75. Now, again, to put that in context, as I said, the industry average is 26. So we are almost 3 times better than competition, right? 3 times more accurate. And finally is the runtime solution I mentioned. So we primarily have 2 products. Inspect is our code analysis solution, and Protect is our runtime solution. I'll show both of these in the demo. What Protect does is when you find a vulnerability in development with our code analysis solution, that information is provided into the agent. We have an agent that can be instrumented with the application. You can do that either in test or in production. Test is like an IaaS use case. That's an interactive application security testing use case, wherein the agent is now monitoring the application. And then when you run all your test cases against it or your traffic against the application, the agent knows what vulnerable patterns or what vulnerable paths that we discovered in the analysis is actually being hit. Right? It does a lot of benefits. One, it confirms reachability as to whether those vulnerabilities are actually reachable in the application when it's running. Second, it could even detect dead code. It could say that, hey, you've run all kinds of traffic against the application, but these paths are never exercised, right? So it could mean that, okay, you have dead code in your application, which Maybe you could even look at refactoring and getting it out. And third is if the path is actually hit, we can sample the traffic that's coming in. So it gives all relevant information to developers saying, hey, this is the source, this is the transformation, these are the things, this is the payload that was used to hit this, and you could then replicate it, you could run it with like something like a burp suite, and you could then figure out how to best fix the vulnerability. And you could even put that agent in production, where you could put it in blocking mode, and you could even block these vulnerabilities in real time in runtime. All right, so that's that protection layer I was mentioning, where you're not fixing it. It might take you time to fix something, but you're still being protected against the vulnerability. So let me quickly switch to a demo, and then we can get into Q&A. So to do the demo, what I have is a repository on GitHub, and I want to walk you through what a developer's experience would be using ShiftLeft with CircleCI. Now, in order to integrate CircleCI into ShiftLeft, the first step would be one of the orgs that Sam just mentioned. So we have a ShiftLeft org published on CircleCI.com. So we are a partner, and we have this official org listed. And if you scroll down, it gives you all the details of, okay, how do you invoke the org, examples of how you would use the org, how you would invoke the analysis, how do you specify what's the target to be scanned, what is the name. So all these parameters are listed here. Right, so this is extensive documentation, examples, everything is listed here on this org page. Right? So it makes it slightly more easier than having to figure out how to integrate ShiftLeft directly into the YAML file. Now, once you have done that, as Sam was pointing out, you check in your YAML file into the source code repository. Right, so I've got a .circleci folder in my application here. Now, inside the folder is the YAML file, which is the entire configuration. And this application here, Hello ShiftLeft, is an application that we have purposefully built, which contains a lot of vulnerabilities. And what I would do here is, let me go into one of the code files. And the names of the files, so patient controller, so that's written as if this is like a healthcare application, right? So it deals with healthcare information. It's got some sensitive information that it deals with. It's got a lot of SQL injection type of vulnerabilities as well. Now, as part of the workflow, so imagine I'm a developer, I'm on the source code repository, and then I'm debugging this endpoint in the application, right? So it's a /patients. Excuse me. So it's a /patients endpoint on your application, and I'm debugging this, and I'm like, okay, pardon me. I'm debugging, and I'm like, okay, something is wrong here. I need to find out what is going on. And so I'm saying, okay, let me add in this line, wherein I'm going to write all patient information into a log file. Now, at first note, it might look like it's a single line change, what could go wrong. But there's a lot of repercussions behind the scene, right? So now, as I said, this could be a healthcare application, right? So, and this patient information is PII data. That's personally identifiable information. And depending on what you're writing into, so you're writing into a log file, just looking at this line, you have no clue where this log file is going to, right? I mean, it could be writing onto disk, it could be writing into like an S3 bucket. You don't know if that information is secured in flight. You don't know if that information is secured at rest, right? So at motion, at rest. And you don't know who has access to that information. So there's a lot of repercussions behind the scene. That if the developer was to be just doing it on his or her own single mission in a controlled environment, it's okay. but this is not something you should be allowing to be checked in and merged into the main branch. Now I make that single line of change. I'm saying, okay, hey, I'm going to create a new branch and I'm going to create a pull request. So I'm proposing a file change. It's a single file, so I'm not going to add other files to the merge. I'm directly going to create the pull request. Now, when I create this pull request, immediately you see the CircleCI icon here. My GitHub has been integrated into CircleCI, and Circle has been monitoring my repository. So now it realized, hey, there's been a change made. I'm going to go in and do what I've been told, and all of that is controlled using the YAML file. Now let's go into the details and realize I'm still on GitHub, right? I'm still in my developer workflow. I'm not going to like the CI environment. And I realize, okay, the first step that Circle is being asked to do is to build the source code. Right now, building the source code is a basic sanity check saying, hey, if a developer was to make a change, is that going to fail the build? Because if that's the case, then yeah, there's no point even reviewing the source code. The developer has to fix what's broken. So that's one. And that happened in, say, less than 40 odd seconds. Right? And then that is pretty involved, where Circle brings up a container. It's going to pull the latest from Git. It's going to, like in my project, there's a Java project which is built on Maven. So it's going to invoke it. It's going to build it. It's going to produce the artifact. And I'm also using workflows here. So if you remember what Sam showed as the graph where there's multiple paths involved, you saw that ShiftLeft was blocked till build finish, right? So it's a job which is depending on the first job. And you can do this because I cannot analyze unless the build goes through, because there's no point doing it in the first place. So once that finished, the second job was invoked. And let's see, when I click on this, it opens up the Circle website. And I can see details of, okay, what happened. It took 23 seconds. This is all the things that it did, spinning up the environment, all of these things it did. And it persists to the workspace. Now, what does that mean is the output of the build, in this case, it's a Java file, so the artifact, the jar file, I'm persisting to the workspace. So because the build container and the container that I'm doing my analysis in are two different ones, right? So I'm persisting that. And let me go back here. It's doing the code analysis. Now let me explain what is happening in these steps. So if I were to go into the details. So it first, again, spins up a container, attaches the previous workspace, and it's installing the ShiftLeft agent. Now this is a single command line tool that runs on Linux, Windows, and Mac environments. And this is the agent which creates the graph of your source code, right? And that graph is then uploaded onto the ShiftLeft SaaS backend, wherein we run all our policies and checks and analyze the graph, looking for vulnerabilities in the application. Now, once that happens, we then ran the application with our ShiftLeft agent. And that agent takes the output of the analysis, which pretty much says, hey, these are all the vulnerabilities that I have found. These are all the sources, things, and transformations, and all the paths for the vulnerabilities. And the agent creates what we call as a security profile, and it is then in a listening mode. And then I'm running a bunch of test cases against it. So I'm running a bunch of traffic against the website, and then is asserting the build against security standards. Now, what does that mean? ShiftLeft provides a lot of information over our APIs. Pretty much anything that you can see on our UI is available over our API. And we have something called as build rules. Now, a build rule is simple, saying in any of my software, I should not have critical SQL injection attacks, right? So it could SQL injection vulnerabilities, right? That could be a build rule. And if any source code change makes that policy fail, wherein if I were to do something which creates a SQL injection which is of type critical, then our APIs would return a fail, which Circle understands. Circle said, okay, ShiftLeft says the API says there is some vulnerability that matches the pattern, and you see red here, wherein the analysis is marked as a failure. Now, going back to GitHub, if I were to refresh this, if I go into checks, it says, okay, so ShiftLeft code analysis was marked as failure. And so you see it's propagating. It went from ShiftLeft, it went into Circle, Circle understands it, it propagates it back to GitHub, and GitHub understands it. Right? And so it said it failed. Now, all of that happened in 3 minutes and 11 seconds, right? So, and as you can see, it was completely automated, right? I literally made a code change, created a pull request. I could walk away, get a cup of coffee, be back, and all of these things are done in the backend. And I was told whatever change I made is not passing the test. Now, I'm still on GitHub, right? I'm not leaving my repository. I go into a conversation, and here there's a comment that's been automatically generated saying ShiftLeft found vulnerabilities that violate policy, right? And then go here for more details. And if you scroll down, since CircleCI let GitHub know that all the checks have failed, GitHub says, okay, all these tests must pass before you're allowed to merge, right? So you're not even allowed to merge the source code. And so at the pull request level, we were able to scan, find, and report on any vulnerabilities that were introduced. Now, the last thing I want to show you is the ShiftLeft UI, right? So I click on that link, it launches the ShiftLeft dashboard. So this is shiftleft.io. And so Jan 21st, the scan that we just did, it says, okay, there are new vulnerabilities that were introduced. This is the entire list of vulnerabilities. And a couple of things to note. One is, if you see here, so this is what is the vulnerability, the details, where was it found, and details on, okay, was there anything that we detected in runtime, right? So that basically means, did the agent also see this? So in this situation, this remote code executions, the agent did not see those in runtime, right? So maybe those are not reachable. At the same time, these cross-site scripting attacks, of 63 calls that came in, all 63 were marked as security events. So all of them were hitting the vulnerable flow. And to give you some details, so I can go into the flow. We give you the entire flow of the vulnerability, starting from the source, including line number and file names and the methods. All the transformations that go in between, it will pass through multiple files in your project, and the destination or the sink that it ends up being. So again, line number, what method it's being used. So for an example here, so this is cross-site scripting. Why is it so? There is some Java file, there is a /debug endpoint where there is a variable that is customer controlled, that is editable or modifiable by the customer. It's going through a lot of transformations, and in none of these transformations we see any kind of sanitization or parameterization, if it's like a SQL injection, any kind of checks and balances to prevent cross-site scripting from happening. So we don't see any of that in this flow. And it is ending up in a string builder, which is then being used without any of these checks. And so it's a classic cross-site scripting example. Different things that you can do with this. There's information on how, if say your developers are not familiar with security principles, it gives you information. It links you to like the CW and OWASP databases where you can read more. You can look at examples of how you could fix these. And you can also integrate with your other workflows. So for instance, you can integrate with Jira. You can pass this on to like a bug tracking system, and then you can track it through those systems. So that's a quick overview of how we integrate with ShiftLeft, how you could integrate code analysis into every single pull request, and how your developers would work with this workflow. And going back to the slide, so what we saw is automating security. We didn't get time to cover these. this is a whole topic of its own, which is like another 1 hour worth of content. But similar to how we did the technical vulnerabilities, we have features like, say, how you can detect secrets or sensitive information in your application. We can also confirm the reachability and help prioritize remediation, and a sample of customers that use us today in production environments. The last slide, ShiftLeft, like Circle, there's a free offering. Just you go to shiftleft.io/register. You can sign up for the free offering of ShiftLeft Inspect. Some things to note, all supported languages we have today as part of the free offering. It supports things like OWASP top 10, sensitive data leaks, all the things that you saw like pull request integration, etc. It is free. You can do up to 300 scans a year, almost a scan a day. And it is free for up to 200,000 lines of code. Right? So the most major projects you can easily scan with the free offering. So that's a quick overview of how we integrate. And so Sam, shall we open up for questions?
Oh, yes. Thank you, Aaron. And we actually have a few questions already in line. One of them is, can ShiftLeft be used with Jenkins, or does it only integrate with CircleCI?
Oh, so yes, it integrates with pretty much any CI platform. CircleCI is where we have the org defined, so it makes it a bit easier. But yeah, some of the customers that I showed you, they use it with Jenkins, Azure DevOps. It could be on-prem, it could be cloud. It really doesn't matter, right? So as I said, it's a single command line utility that how we invoke the graph and the scan. And so you could integrate with any CI system. And you could even run it standalone, right? So if you have developers who have controlled environments who might not have CI access, they could even run it off their laptops. So yeah, so the answer is yes.
Awesome. All right. And we also have a few questions around what kind of languages that ShiftLeft supports for scanning. So specifically, we have customers asking about JavaScript, Node.js, or Ruby on Rails. So can ShiftLeft scan those languages?
Sure. So yes, so we support Java, .NET, Scala. We have early access for JavaScript. We have support for Golang. And Ruby on Rails is on the roadmap. We don't have it in GA yet.
Got it, I see.
Yeah, and then those details are on the website as well. You can check it out there.
Awesome, thanks. And in terms of average scan times, like what average scan times do you see for projects typically for ShiftLeft?
So the graph that I showed you is customer data, right? So wherein, if I were to quickly go back to this one here. So this is all the things on the left-hand side is average data based on thousands of scans across our customer base. And then what we did is to split it out by size of the application, so lines of code. So this is real data from our customers. So on average, we don't see many million plus applications because those do exist. It's just that we don't have hundreds of samples so that we can give you a good number there. But say on average, 1 million lines of code, as I said, is less than 15 minutes.
I see, cool. And okay, so I also see a few questions, 2 questions about the kinds of vulnerabilities that are being scanned. First one is, can a user define what types of vulnerability in the code that the code analysis should be looking for?
Yes, definitely. So that's one of the big advantages that we have, where our what we call as a policy language is exposed to the customer. Now, what does that mean? So as I mentioned, vulnerabilities are of 2 types. Technical vulnerabilities or business logic vulnerabilities. But both of these are, so one could be straightforward patterns, and second could be symptoms in the source code, right? So what does a symptom or a pattern mean? Now, let's take a SQL injection attack as an example. How does a SQL injection come into play is you have something which is user controllable, right? So it could be, say, a form, a parameter, a get, or a post, or whatever parameters are coming in from the user. And it then goes through a lot of functions, logic, whatever in your source code, and it finally touches the database, right? It could be a read operation, a write operation, whatever may it be. Now, if this user controllable data or parameter goes all the way to the database without being sanitized, parameterized, checked for like SQL injection patterns, that leads to a SQL injection attack. That's the basic premise of a SQL injection. Now, there's multiple things at play here, like how long is that flow? Can the user modify it at the very beginning? That's where they can modify. And can that parameter go through all these transformations without being changed so that it can hit the database and do what the attacker is trying to do, right? So that's a SQL injection vector. Now, this is definable, right? So wherein I say, okay, in our graph, you have sources, you have sinks, and you have transforms. And as you saw, you have that flow. You are saying, okay, I want to look at things that are these types of sources. I want to see if there is something in the transforms which is of this type. And I want to see if sinks are of one of these types. And if it matches these, it's either a vulnerability, or I could say this is a vulnerability which has been accounted for. Right? So this kind of what I call as a policy is editable by customers. And these then lead to conclusions. Conclusions is A leads to B leads to C is a vulnerability. A leads to C leads to D is a vulnerability that is fixed in code. And so these are conclusions that you can emit in the policy. And as I said, all of these are editable by customers. So yes, you can do custom vulnerabilities.
Got it. All right. And also slightly similar to that question, does ShiftLeft also catch, or does it identify the OWASP top 10 vulnerabilities in REST endpoints?
Sorry, what's the question? Do we do OWASP, or do we do things outside OWASP?
Oh, do you identify the top 10 vulnerabilities?
Yes. So as is listed on this slide here on the right-hand side, yes. So OWASP top 10, SANS top 25, even vulnerabilities outside of these, because OWASP top 10 is purposefully made broad because there's a lot of ways in which these vulnerabilities can be done. But things like SANS top 25 is a little more narrow in scope. Yes, so we do OWASP top 10, and we do vulnerabilities that fall outside of these as well. Like business logic vulnerabilities, for instance, OWASP is working on classifying them and creating classifications around them today. There's no specific category in OWASP top 10 which they fit, but we do those as well.
I see. Got it. Cool. Thank you. And in terms of the code that ShiftLeft scans, do you just scan, you only act on binaries, or can you also compile the code on ShiftLeft?
Good question. So it depends on the language. So for today, for Java, for instance, we work off the bytecode. That's the build artifact or the jar file or the war file. So for those, we integrate with a CI system like Circle, right? Where Circle would pull the code, build it, replicating that CI magic. It's not worthwhile trying to do it as a separate platform when you already have a CI. That's why it's best to integrate ShiftLeft into a CI. So Circle will do its magic, it will build it, it will do as it is, and we add a job as part of that workflow wherein we can be invoked. So that's for languages like Java. For languages like, say, JavaScript or Golang or Python or .NET, for instance, we can work off the source code directly, right? For .NET, we integrate with the Microsoft build tools. So it's like half compilation, half scanning. For things like JavaScript, we can directly scan off the JavaScript files itself. So it is kind of language specific. But for all of these cases, it's best to integrate into a CI because your CI environment already has access to your repository. It has the permissions to pull the code, build the code, and we don't have to replicate any of that with another environment. And that's why I said, if you're integrating into a CI environment that already exists, you could easily integrate ShiftLeft in like less than 15 minutes.
Got it. And so just to make sure I understand that correctly, specifically for the Java context, so you're saying ShiftLeft can scan the source files for Java as well as the Java binary afterwards?
No. So for today, for Java, we only do bytecode.
Okay.
For .NET JavaScript, for Java and Scala, because both of them compile into bytecode, we do bytecode analysis. For .NET, Golang, JavaScript, etc., we work off the source code.
I see. Got it. Great. Thank you. And also in terms of for reporting, for instance, does ShiftLeft integrate with other dashboards like Splunk, for instance, or do you only use the dashboard built into your UI?
Yeah, so again, good question. So yeah, a lot of customers of ours, they use different platforms and environments. Some of them use a SIM, some of them use bug tracking solutions, some of them output these as like HTML and PDFs. So what we have done is, as I said, pretty much everything you see on the UI, including the initial dashboard, all the applications, within an application, the complete history of scans of the application. For each scan, all the vulnerabilities, for any vulnerability, the entire the flow, including the sources, sinks, and transformations and conclusions. Who is it assigned to? Is it marked as ignored, fixed? All of that information is available over our REST APIs after you authorize and authenticate. And what customers do today is take that information and then they pipe it into whatever platform they want, right? Because this information is at multiple levels. So for like an executive report, they only require like, say, scan history and at that top level. But then if they were to be doing like vulnerability analysis and vulnerability management, then they drill down into details. Right, so we do have executive reporting output directly as like PDFs, etc. But for things like integrating into SIM, customers use us today using our APIs.
Okay, got it. All right. And okay, so it looks like we're running short on time. So we're going to take two more questions. One, what would you say is the pricing model for ShiftLeft? Do you price per number of by project identified, by users, by lines of code? Like how does the platform charge?
Perfect. Yeah. So one thing when we were looking at how to price our solution, one thing we realized is legacy vendors charge, most of them charge on number of applications or projects. Now, we realized that is not a good measure because what is an application is very tough to define in this day and age, right? It could be a microservice that does one specific thing, or it could be a monolith that does everything. And being charged the same for both is not real. So we wanted to do true consumption-based pricing. So what we have is two models. One is lines of code. So literally how much lines are we scanning? So what are we protecting is what you pay for. And of course, it's a scaling model. So the more you consume, the price per line of code starts falling. We do also have a model which is based on number of contributing developers. The reason we have it is a lot of big companies, they have applications which they do not actively develop, right? So they have a lot of legacy applications which are just there. They might not even touch it, but they still want to scan it once in a while. But then they have a core set of developers who are actually working on the latest stuff. So in those situations, charging for the entire line of code might be overcharging. So we have a developer-based pricing as well. So line of code-based pricing or developer-based pricing. Those are the two models we have.
Great, thank you. And also you touched on one of the topics for actually the lead into the last question, which is legacy code. Let's say I have a lot of projects at my company or my team right now. We maintain a lot of legacy projects and we want to incorporate ShiftLeft. How much work, how much rewrite do I need in order to get ShiftLeft to work with my projects?
So there is absolutely no change in source code or application that is required, right? So as you can see, that application, like you could literally take an application off your GitHub repo as long as it's one of the languages we support, and you can start scanning it because there's nothing that you add into the source code or instrument or anything. So that's one. Second is if the question is around, hey, is it a language that we don't support? Like, is it like in COBOL or something? Yes, so today we would not be able to support it because that language we don't have support for. But if it's one of the languages we support, yes, we can scan it. And the third is if it's a question around, hey, it's a legacy application, maybe it's not integrated with a CI system, how do we scan it? As I said, yeah, we don't need to have into a CI system. If there is a repository where you have access to the source code, if it's a language like Java where you must be building that application in some way or form, if we can get access to that build output, we can still scan it, we can still report on it, you get all the capabilities. So I hope I answered that question.
Awesome, yes, thank you. All right, thank you, Aaron. Again, also that concludes the webinar. We're running out of time here. I wanted to say thank you to you, Aaron, and your team at ShiftLeft for the webinar, and also for contributing to the ORB to our ORB registry. And to all the attendees, thank you for attending. I hope you've learned how ShiftLeft can help you secure and guarantee quality in your coding projects, as well as how integrating that with CircleCI just helps automate and optimize your build pipelines and reduce the amount of overhead you need in order to maintain and guarantee your projects. If there are any other questions that come up, if there are any more information you'd like to know, feel free to reach out directly to Aaron or to I. We'll provide our contact information along with the slides afterwards. Thank you all and have a good day. Bye.